Imagine holding a piece of gold in your hand, a shiny, precious metal that's been treasured for centuries. But have you ever wondered where it came from? Not the jewelry store, but the cosmos itself. For decades, astronomers have puzzled over the origins of heavy elements like gold. Now, a groundbreaking discovery hidden in 20-year-old space mission data might hold the key. Magnetars, the universe's most magnetic stars. Buckle up, because we're diving into a cosmic mystery that's as dazzling as gold itself. Let's start at the beginning 13.8 billion years ago, with the Big Bang. The universe was born, and with it came the lightest elements, hydrogen, helium, and a sprinkle of lithium. Over time, stars formed, lived, and died in spectacular explosions, forging heavier elements like iron. These became the building blocks of new stars and planets. But gold? That's a different story. Gold is heavier than iron, and its presence across the universe has been a head-scratcher for scientists. As Anirudh Patel, a physicist at Columbia University, puts it, it's a fundamental question about the origin of complex matter in the universe. A puzzle waiting to be solved. In 2017, astronomers got a major clue. They witnessed a cosmic collision between two neutron stars, dense remnants of exploded stars. This cataclysmic event, called a kilonova, sent ripples through spacetime, known as gravitational waves, and unleashed a burst of light called a gamma-ray burst. Most importantly, it acted like a cosmic gold factory, producing heavy elements like gold, platinum, and lead. Kilonovas seemed like the answer to the gold mystery. But there was a catch: most neutron star collisions happened in the last few billion years. So, how did gold exist in the early universe? Enter magnetars. These are neutron stars, but not your average ones. Magnetars are incredibly dense. 1 teaspoon of their material would weigh 1 billion tons on Earth. What makes them special? Their magnetic fields are so powerful they could wipe out your credit card from halfway across the solar system. Scientists believe the first magnetars formed just 200 million years after the Big Bang, when the universe was still in its infancy. And here's where things get wild: magnetars can unleash massive flares of radiation during events called starquakes. Starquakes are like earthquakes, but on a cosmic scale. Just as Earth's molten core causes its crust to shift and quake, a magnetar's superfluid core stresses its surface, triggering explosive bursts of X-rays. Sometimes, these starquakes are so powerful they eject material from the star's crust at incredible speeds. And according to new research, these eruptions might be another way gold is forged in the universe. The breakthrough came from digging into old data. Scientists, led by Anirudh Patel, revisited gamma-ray signals from a giant magnetar flare captured in 2004 by NASA and European Space Agency telescopes. At the time, astronomers didn't know what to make of the signal. But when Patel's team compared it to their theoretical models, it was a near-perfect match. The gamma-ray glow looked exactly like what you'd expect from heavy elements like gold being created in a magnetar flare. Data from NASA's RESI and WINS satellites backed it up. Over the 2024 holiday season, the team realized they'd struck scientific gold literally. But not everyone's convinced. Dr. Eleonora Troja, who studied the 2017 neutron star collision, cautions that the evidence for gold from magnetars isn't as strong as what we saw in kilonovas. Magnetars are messy, she says. Creating gold requires precise conditions, and a magnetar's flare might produce lighter metals like silver or zirconium instead. Still, the idea of magnetars as an alternative gold factory is tantalizing. The team estimates that magnetar flares could account for up to 10% of the heavy elements in our Milky Way. So, what's next? In 2027, NASA's Compton Spectrometer and Imager, or COSI, will launch. This gamma-ray telescope is designed to catch magnetar flares in action and pinpoint the elements they create. It could confirm whether magnetars are indeed cosmic goldsmiths or reveal other sources of heavy elements across the universe. The hunt for gold's origins is far from over, but each clue brings us closer to understanding our place in the cosmos. The next time you admire a gold ring or a shiny gadget, think about this. The metal in your hand might have been forged in a magnetar's fiery outburst, billions of years ago, in a corner of the universe we're only beginning to explore. Isn't that a story worth its weight in gold? If you enjoyed this cosmic journey, hit that like button, subscribe, and ring the bell for more space adventures. Until next time, keep looking up.